Alright guys, welcome to my YouTube channel. My name is Favor and today we'll be looking at chemistry, and the topic of discussion is the periodic table. The periodic table is a table that arranges elements into groups and periods, and with the table we can understand the basic chemistry of such elements. And Tony Lavosov is the first person to classify those elements into metals and non-metals. Later on, the person of Dmitry Mendeleev, who is known today as the founder of the periodic table, was the first to make an attempt into grouping these elements into this periodic table, and he is a Russian scientist. So the table we are using today is a work built upon the work of Mendeleev. Mendeleev grouped the elements in order of their atomic masses. But in modern findings, the elements are grouped according to their atomic numbers in their increasing order. So the modern periodic table it groups elements into this table in increasing order of their atomic numbers. And that brings up the law, the modern periodic law, which states that the properties of an element are a periodic function of its atomic number and not the mass number, as against what Mendeleev postulated earlier on. So, which means we are trying to see that to know the property, the chemical nature of an element, it is vested on the atomic number. And also, it is what we use to place the element into the group and the period it belongs in the table. So, the table consists of vertical columns called groups, and they are 8 in number. This is group 1, group 2, up to group 8, otherwise known as group 0. And consists also of 7 periods, which are the horizontal rows. So this is a period, and this is a period. Now, across a period, there is a progressive addition of 1 electron. So that is across the period. And what makes us to know the period an element belongs is the number of shells that element has. Take for example, an element like carbon, which is 6. Carbon is 6. This is its configuration, K2L6. This is a shell, K shell. This is the L shell. It therefore means that carbon is in period 2 because there are 2 shells. So carbon is in period 2. Period 2. Then let's now know the group. To know the group an element belongs, we use the valence electron. The valence electron is the outermost electron of an element, and that is what participates in reaction. So the valence electron here for carbon is 6, because in the configuration, so carbon has 8 electrons. So this is supposed to be 4, okay? So though carbon has 6 electrons, there's only 4 valence electrons. So carbon is tetravalent. Now, it therefore means that the group carbon should belong is 4. So let's see if it works. Group 4, so this is group 4, then period 2, this is period 2. So when you trace it down, you see that carbon is where it's supposed to be. Alright. Now, all the groups have their unique properties. But right away, let's go into what is known as the blocks of the periodic table. But before we look at the blocks of the periodic table, let's look at how we configure elements in the periodic table using the SPDF notation. So this is 1 to 8, then this is S, this is P, D, this is S, this is P, this is D, and this is F. The S block takes a maximum of 2 electrons, P a maximum of 6, D a maximum of 10, and F a maximum of 14. So what is happening is that there's a progressive addition of 4 electrons to the preceding block to get the preceding block. So from here now, the principle used in this process is called Aufbau's principle. Aufbau's principle. and it states that when filling electrons, they are filled in increasing order of their energy level. That's the Albers principle. So by this principle, we go with the first one is 1s, second one is 1s, then the next is 2s. After 2s, we get to 2p. From 2p, we get to 3s. From 3s, we get to 3p. From 3p, we get to 4s. Then 4s, the next one is 3d. So this is continuously, okay, and so on. Now, from this, we can fill elements into what is known as blocks. So let's see the blocks of the periodic table. Blocks of the periodic table. There are 4 blocks, S, P, D, and F block. So let's start with the S block. The S block. The S block consists of elements that are filled into like elements in period, in group 1 and in group 2, that their electrons are in S block. Those are what we're going to be looking at now, and they are found in group 1 and in group 2. So let's see how we get. So let's see example now. We have hydrogen. Hydrogen is simply H1 is 1s1. The next there is lithium. Lithium is 3, that is 1s1, 2s2. 1s2 rather, 2s1. Then after lithium we have beryllium. Beryllium is, this is for group 1 now, we're taking hydrogen and lithium for group 1. Then taking a group 2 element like beryllium, beryllium is 4. This will give us 1s2, 2s2. Then magnesium is 12. 1s2, 2s2, 2p6. So what I'm using now is this 1s2, 2s2, 2p6, and then 3s2. So 3s2. 12. How do you count? 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. So this is magnesium. Now let's see all the elements I just skipped. These first 2 are for group 1. These other 2 are for group 2. What do you observe? They all end with S, S, S. And that is the reason why we said that all elements in group 1, these 2, plus elements in group 2, these 2, are in what? In the S block. Alright. So we have gotten the S block now. Then apart from that, we should also know what the concept of unpaired electron, because it will be asked in exams to calculate the number of paired electrons. So let me see use this carbon I used earlier on. So carbon, or let me use oxygen, since I've used carbon before. So oxygen is 8, which is 1s2, falling back to this again, 1s2, 2s2, 2p6. Okay, it's like we have earlier exceeded 8. So let's count. This is 2 plus 2, 4. So remaining 4 to make a balance. So put 4 in here. Like I said, S is taking the maximum of 2. This is already correct, so it's balanced. This is also S balanced. But P has to take a maximum of how many? A maximum of 6. Here it's only 4. So this is how you configure the P block. So you divide it into 3 degenerate orbitals. This is called X, Y, and Z. Since P has to take a maximum of 6, and there are 4 there, what do? I can simply say let it go like this: 1, 2, 3, 4. It is now balanced. But this will be what? Wrong. Why? Because there's a principle in operation here called the Hund's rule. Some persons pronounce it Hund's rule. H-U-N-G, Hund's rule. And Hund's rule says that when filling electrons into this block, that electrons must occupy singly first before they start pairing. And what is the reason behind that? Because of mutual repulsion which exists in each orbital. So what we will now do is that we first evenly distribute these 4 electrons. So this 1, this 2, and this 3. The 3 orbitals have gotten each 1 electron, and we are left with 1. So that extra one now comes to pair here. So which means this X part of it is well paired, but the Y part is not paired here. Z is not paired here. So 1, 2. Therefore, oxygen has 2 unpaired electrons. Phosphorus has is 15. So P15 will give us 1s2, 2s2, 2p6. After 2p, what do you have? 3s2. 3s2. After 3s, we have 3p. 3p. I don't know what should be here now until we count. So this is 2 plus 2, 4 plus 6, 10 plus 2, 12. So we are left with 3 to make it 15. Put a 3 there. So let's check. S is 2 balanced. S is 2 balanced. Why is it balanced? Because S can take a maximum of 2 electrons. P maximum of 6, correct. S correct. But P here has to take a maximum of 6. Here it is taking only 3. Which means if we draw that same structure, 1, 2, X, Y, Z, this 3 will go singly, singly, singly. Which means this is not being paired, this is not being paired, this is not being paired. Hence, phosphorus has 3 unpaired electrons. And that is obtainable for any element you are asked to calculate the number of paired electrons. So we have seen that group 1, block, the S block consists of elements in groups 1 and 2. Then the P block, so the P block consists of elements in groups 3 to group 8. Group 8 is otherwise known as group 0. So let's check group 3. Group 3, an example is what? Boron. Boron is the 5th element. So boron being the 5th is 1s2, 2s2. After 2s2 is 2p. So we have 2p. Here is already 4, making here 1 to complete 4. Okay? We have put an element in group 3. Let's now pick this is group 3. Okay? Group 3. Let's check from group 4. Okay? What's in group 4? We have carbon. Carbon is in group 4. 1s2, 2s2. Carbon in group 4. Okay? 1s2, 2s2. 1s2. Group 3. Boron. We have 5. 1s2, 2s2, and this. Carbon is 6 rather. Okay. Sorry for that. So we have, after 2s2, we have 2p2. That's how we have 6. So let's now check for group 5. Group 5, an example there is nitrogen. Nitrogen is 7, which is 1s2, 2s2, and 2p3. Okay? To save our time, I will just use these 3 examples. Okay? It will work for the rest. What do you observe? This ends at P, this ends at P, this ends at P. Which means group 3, group 4, group 5, and also group 6 and 7 to 8 are in the P block. So group 3 to 0 or to group 8 are in the P block. So we have been able to see S and P block. Let's now see the D block. So the D block, they comprise elements that are from scandium to zinc. And from scandium to zinc are known as the first transition metals. They are the first transition metals. Group D. While group F, the F block, they make up the inner transition metals, which are divided into 2. We have the lanthanide series and we have the actinide series. Okay? The lanthanides are found in period 6. The actinide are found in period 7. Together, these both make up the inner series, which are in the F block. So that is all for the groups elements belong. Let's now go to look at the family of elements, otherwise known as the groups of elements. So groups of elements. Now some tests will tell you that we have about 118 elements and this and the rest. Well, nobody wants to bother you with how many elements you have, because every day new things are being discovered Alright, so that's why in my video I don't tell you that there are so number of elements, but that is for consumption. If you want to know, you can go and do that research. Now, the elements are divided into groups or families, and there are 8 groups. So the beginning, the first one is group 1. Group 1 elements. Group 1 elements are also known as alkali metals. They are all metals. So what are their properties? 1, they are all metals. 2, they are strong reducing agents because all metals are reducing agents. They are very strong reducing agents. Then 3, they ionize by electron loss, and they can only lose 1 electron. Hence, they are unipositive ions. So they ionize by electron loss, forming unipositive ions. That's 3. Then number 4, we said they are alkali earth metals. How? Because when dissolved in water, let's take for example sodium. Sodium is a solid dissolved in cold water. Take note, it's cold water. It will give us an alkali, which is sodium hydroxide, which is in aqueous form, and a gas will be evolved. This is known as hydrogen gas. Very important for the exams, mostly JAM and WAEC exams. So when group 1 element, not necessarily sodium, it could be any of the group 1 like lithium or even potassium, react with cold water. Emphasis on the word cold water. They tend to give out alkali and they liberate this gas. So in exam, this place might not be given. You might be told X and be asked to identify what X means. So hydrogen gas is always evolved. And this reaction is very, very vigorous. Very vigorous. It is a unique property of group 1 when they react with cold water. And that is the reason why they are called alkali metals, because they are metals that form alkalis when reacted with cold water. Examples of elements in group 1 are hydrogen, lithium, sodium, potassium. Now, all but hydrogen are metals. Hydrogen is a gas, and hydrogen is the lightest gas on Earth or in the periodic table. So this. Now, another thing about group 1 is that they are triosonitrate 5. They are triosonitrate 5, NO3 minus. And also they are carbonates. Carbonate 4, CO3 2 minus. Are soluble. They are trioscarbonates 95 and a carbonate 4 are soluble in water. Let's now move on to group 2. In group 2, they are known as the alkali earth metals. For group 1 was just alkali metals, while here they are the alkali earth metals. Alright? They are very reactive, just like their brother, group 1. But in terms of reactivity with cold water, they are so sluggish. They are so slow. And when they do so, they form alkali and also a gas hydrogen is evolved. Apart from magnesium, the rest can undergo that reaction with cold water slowly. But magnesium only reacts with steam or hot water. Alright, so please take that point down. The other properties or features of group 1 or group 2 elements is that they are divalent metals which ionize by electron loss to form unipositive divalent ions or cations. Okay? And they are also good reducing agents because they are metals, and all metals are reducing agents. Alright, examples are beryllium, magnesium, calcium. These are the elements in group 2. There's something important about them is that they are sulfates. They are tetra or sulfates, and then they are nitrate 5 and they are carbonate 4. They are easily decomposed. Sorry? Not their sulfates, they are nitrate 5, NO3, and they are carbonates, CO3 minus. They are 2 minus. They are heat labile, which means when you heat them, they can decompose on heating. Then we move on to group 3. Group 3, there's no really much thing to be said there, alright, apart from the fact that they are trivalent. Okay? Group 4, they are tetravalent. Group 7, they are the halogens. They are called halogens because they can form salts. Hence, we say they are salt formers. and they include elements fluorine, chlorine, bromine, iodine. They all have the suffix "-ine". Fluorine, chlorine, bromine, iodine. And they are the most reactive